So before we go on to derive the second equation of motion, I'm just going to talk about how we can use a velocity time graph to calculate displacement. So using the area under the graph will give us displacement. Here's a VT graph representing a constant velocity over a given time. If we use the area under the graph method, we can calculate displacement. Let's use our units for velocity and time to show that we're left with a unit of meters for displacement. So velocity is measured in meters per second and time in seconds. If we cancel out, we're left with meters. Let's do this using some values. So let's just assume that velocity is perhaps 10 meters per second and it's traveling for a time of 5 seconds. What's the displacement? So we'll calculate displacement and know that displacement equals the area under the curve. So 10 meters per second times 5 seconds. Cancel out our units for seconds. 10 times 5 is 50. So the displacement, let's now consider an object that's moving at a constant acceleration where its initial velocity is 0 and it's increasing its velocity up to, let's say its final velocity is 10 meters per second. And it travels for 5 seconds. This time the area under the curve is a triangle. So in this case, we use the equation area of a triangle, so half times base times height, which gives us, and if we substitute the values in, that's 10 minus 0, so that gives, and again we cancel out seconds and we're left with 50 times a half, so 25 meters. So the displacement in this case is 25 meters. Let's now look at this third situation where we have a non-zero initial velocity. We can break this motion graph up into two areas now. We've got area 1, which is a rectangle, and area 2, which is a triangle. So the area is now given by the sum of area 1 plus area 2. And area 1 is given by base times height, which is u times t. And area 2 is given by half times base times height. Let's substitute these into the equation. Now recall from the first video, from the equation for acceleration, we can rearrange this to show that v minus u equals at. So that means over here we can replace this with at. So let's do that. And notice here we can multiply the t. So recall the area under the graph gives the displacement. So we've just derived the second equation.